Are you looking for a faster way to calculate conditional functions in Python? If so, you're in the right place. Today, we're going to explore some efficient methods to speed up your calculations. I totally understand how frustrating it can be when your code runs slowly, especially when you're working with large datasets. You're not alone in this struggle. Many developers face similar challenges. Here's the specific question we're addressing today. One user asked, "What is the fastest way to calculate a function like this?" They provided a function that uses conditional logic based on the value of x. Let's dive into this and find a solution together. So what's the issue here? The user is looking for a way to optimize their function, especially when dealing with arrays. The current method processes each element one by one, which can be slow. Let's explore a better approach. And stick around. At the end of this video, I'll share a powerful tip that can significantly boost your performance when working with large datasets. To improve the performance of the conditional function, the user can utilize NumPy's vectorized operations. This allows for faster calculations on entire arrays instead of processing each element individually. The user can achieve this by using NumPy's np.where function. This function allows the user to specify a condition and choose values based on that condition in a single operation. Next, the user should ensure that the input is a NumPy array. This will allow the function to take full advantage of NumPy's capabilities for handling array operations efficiently. Finally, the user can test the new function with a sample array to verify that it produces the correct results and performs better than the previous implementation. Fun fact, did you know that the first programming languages were designed to control machines, not for calculations? We've come a long way since then, but speed is still a priority. Now, let's look at the answers provided by other users. An alternative approach involves using masking for better performance. This method creates a mask for positive and negative values, allowing you to compute logarithms only on the relevant parts of the array. By using NumPy's evaluate function, you can further optimize the calculations. Additionally, by leveraging the numexpr module, you can push the sign into the logarithmic computations. This allows for even more efficient calculations, as demonstrated in the final function. Runtime tests show that this method significantly reduces computation time compared to a traditional looping approach, making it a highly efficient solution. That's it for that response. Let's explore another one. An alternative approach to improve performance is using Numba. Numba allows you to speed up your Python functions by compiling them to native machine code. With just a few annotations, you can achieve performance similar to C or Fortran. The user provides a code example using Numba's nj-decorator to create a fast function that calculates the conditional log function. This method significantly reduces execution time compared to the original function. In performance tests, the Numba-optimized function runs much faster than the original implementation, demonstrating the effectiveness of this approach. That's it for that response. Let's explore another one. An alternative approach to improve speed is to use NumPy's where function instead of select. This method checks the condition and applies the appropriate logarithmic function more efficiently. Benchmarking shows that using np.where is faster. The log_b function executes in about 98 microseconds per loop, compared to 169 microseconds for the loga function. Here's the tip I promised. Always look for ways to leverage vectorized operations in NumPy. This can drastically reduce computation time and improve your code's efficiency. And there you have it. By using vectorized operations, you can significantly speed up your calculations. If you found this video helpful, please subscribe for more tips and tricks on optimizing your code.